Hello everyone, welcome to Brain Blitz Audios. In this episode of Cbse board exam, we'll be dealing with previous year questions of mathematics in Cbse board exams. The chapter that we'll be dealing with is the first chapter in the grade 12 syllabus for Cbse, and the chapter is Relations and Functions. Let's look at our first question. If f and g from real numbers to real numbers are two functions defined as fx is mod x plus x and gx is defined as mod x minus x for all x belongs to the set of real numbers, then find f of g and g of f. So in order to start off in this question, let's define both f of x and g of x. F of x is given as mod x plus x. So that means f of x has the value 2x when x is greater than 0, because this will be positive, and it will be 0 when x is less than 0, so this will be negative. And similarly, we can take g of x as mod x minus x, so that means g of x will be defined as 0 when x is greater than 0. Positive, negative cancel each other. And when x is less than 0, this will be negative. So minus x gives you minus 2x. So these are our functions, f and g. So first we'll be looking at g of f of x. So g of f of x has two scenarios. At x greater than 0, g of f of x, which is defined as g of f of x like this. So we'll put the value of f of x inside the bracket for g. So f of x at x greater than 0 is 2x. So it'll be g of 2x. But g of x at x greater than 0 is 0. So g of 2x will be 0. Now let's find the value for g of f of x at x less than 0. So at x less than 0, g of f of x will be equal to g of 0, since f of x is 0 when x is less than 0. So that means it'll be 2 into 0 minus 2 into 0, because g of x when x is less than 0 is minus 2x. So it'll be minus 2 into 0, which is 0. Let's look at our next combined function, f of g of x. So at x greater than 0, f of g of x, which will be equal to f of g of x in the bracket of f. So we'll put the value of g of x when x is greater than 0, so that is 0. F of 0 will be 2 of 0 equal to 0. At x less than 0, f of g of x will be equal to f of minus 2x. So it will be 2 of minus 2x, which will be equal to minus 4x. So g of f of x is always 0 for all x belonging to the set of real numbers, while f of g of x has two values, 0 and minus 4x, 0 when x is greater than 0 and minus 4x when x is less than 0. So that is our first answer. Let's look at our next question. If R is a relation defined on the set of natural numbers n, such that R is x comma y when x belongs to natural numbers, y belongs to natural numbers, and 2x plus y equals 24, then we have to find the domain and range of the relation R, and also find if R is an equivalence relation or not. So let's tackle our question. So this is our relation R equals x comma y, such that x belongs to n, y belongs to n, 2x plus y equals 24. So what we can find is that since 2x plus y equals 24, y will be equal to 24 minus 2x. So how do we find the domain and the range? The domain is the value of x, while the range is the value of y. So for x equals 1, y is 24 minus 2, that's 22. For x equals 2, y is 20. For x equals 3, y is 18. For x equals 4, y is 16. For x equals 5, y is 14. For x equals 6, y is 12. For x equals 7, y is 10. For x equals 8, y is 8. For x equals 9, y is 6. For x equals 10, y is 4. And for x equals 11, y is 2. And since the function is defined on the set of natural numbers, the value for x equals 12 will be 0, which is not in the set of natural numbers. So these are just what we get by putting the value of x in the equation y is equal to 24 minus 2x. So we get the value of y like this. So according to our table, the domain of the function will be the set of numbers from 1 to 11. And the range will be the set 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, and 22. This is the set of numbers that form the range of the function. So our relation R will be 1, 22. We're doing it like this. Since the R is given as x comma y. So put the value of x and y together. So 1 comma 22, 2 comma 20, 3 comma 18, 4 comma 16, 5 comma 14, 6 comma 12, 7 comma 10, 8 comma 8, 9 comma 6, 10 comma 4, and 11 comma 2. That is our relation R. We found the domain and the range. The second part of the question is asking us to find out if R is an equivalence relation or not. What are the conditions for R to be an equivalence relation? For R to be an equivalence relation, R has to be reflexive, symmetric, and transitive. So when R is satisfying all of these three conditions, we can call R as an equivalence relation. How do we solve this? Let's look at each condition one by one. For a function to be reflexive, we need to prove that for any element A, A comma A, the element A comma A belongs to the relation R. So when we look at the element 1, we find that in the relation R, there is no element called 1 comma 1. So we can write that 1 comma 1 does not belong to R for an element 1 in the domain. So therefore, R is not reflexive. So by this point, you would know that R is not an equivalence relation, but since this is a subjective question, we need to find out the condition of the other properties. So let's look at the next one, symmetric. For a function to be symmetric, the element A comma B belonging to R must ensure that the element B comma A also belongs to R. So let's look at our first element, 1 comma 22. This belongs to the function R, but its reciprocal, that is B comma A, which in this case is 22 comma 1, is not found in the relation. So 22 comma 1 does not belong to R. So therefore, we can find out that R is not symmetric. What about the third property, transitive? For R to be transitive, if A comma B belongs to R and B comma C belongs to R, that should prove that A comma C also belongs to R. But in this relation, suppose if we take 2 comma 20, then there is nothing called 20 comma something. So we cannot prove that R is transitive, and it is not transitive. So we can write that there are no elements such that A comma B belongs to R and B comma C belongs to R to imply A comma C belonging to R. So we can prove that R is not transitive. So therefore, R is not an equivalence relation, hence proved. And when we are writing down the final answer, it helps to write the domain and range as well. So the domain is, as we said, the numbers 1 to 11, the set of numbers 1 to 11, and the range is 2x, where x belongs to n, x less than or equal to 11. So that implies 2, 4, 6, 8, up to 22. So I just wrote it in another format, but it's still the same range. So this is our final answer. Now let's move on to the final question. If the set A is defined as the set of real numbers minus element 3, and B is defined as the set of real numbers minus element 1, and we consider the function f from A to B defined by f of x is x minus 2 by x minus 3 for all x belonging to A, then we need to show that this f is bijective, and we have to find the inverse function. So to start off, we write that f of x is x minus 2 by x minus 3. F is from A to B, and A is r minus 3. B is R minus 1. So the first part of the question asks us to find out whether f is bijective. So in order to find whether f is bijective, to show f is bijective, we need to prove that f is 1, 1 and on 2. So let's first prove that f is 1, 1. So we consider f of x1 be equal to f of x2. So since f of x is x minus 2 by x minus 3, let's put in the values. So x1 minus 2 divided by x1 minus 3 is equal to x2 minus 2 divided by x2 minus 3. On cross multiplication, we'll get x1 minus 2 into x2 minus 3 equals x1 minus 3 into x2 minus 2. Now what we can do is we can open the brackets. So we'll do multiplication. So we'll get x1, x2 minus 2x2 plus 3 minus 3x1 plus 6, which is equal to x1, x2 on the other side, minus 3x2 minus 2x1 plus 6. So over here, x1, x2, and 6 are common, so we can cancel both of them. And so what we'll get is minus 2x2 minus 3x1 is equal to minus 3x2 minus 2x1. So let's group together the terms having the same variable. So what we get is minus 2x2 plus 3x2 giving 3x1 minus 2x1. So basically x2 equals x1, which is the same as x1 equals x2. So when we considered f of x1 and f of x2 are equal, we found that x1 is equal to x2. So f is a 1, 1 function. Now, let's figure out whether f is on 2. So to prove whether f is on 2, let's take y is equal to f of x. So y will be equal to x minus 2 by x minus 3. So on taking this to the left-hand side, we'll get x, y minus 3y is equal to x minus 2. So this is after taking this to the left-hand side and opening the bracket. Now we can group the x terms together. So xy minus x equals 3y minus 2. Taking x common, we'll get y minus 1 in bracket. So x into y minus 1 equals 3y minus 2, which we can use to take x as 3y minus 2 by y minus 1. So the value of y can have all values of the real number line except 1, because if it has 1, then the denominator becomes 0 and the function will not be valid. So since the range of y is also r minus 1, so since the domain of y, which is the range of x, is r minus 1, so this is our range. And it is equal to the codomain. Our codomain was also r minus element 1. And we can prove that C. So B is given as r minus 1. So the range equal to the codomain, and when the range equals the codomain, f is onto function. So therefore, we get that f is a bijective function. Now, since f is a bijective function, we need to find f inverse of x. Now we know that when we took y is equal to x minus 2 by x minus 3, we got the relation x is equal to 3y minus 2 by y minus 1. And since y was f of x, since y equaled f of x, we can prove that x equals f inverse of y. So f inverse of y equals 3y minus 2 by y minus 1. So on interchanging y with x, so we're just interchanging the variable, we'll get f inverse of x as 3x minus 2 divided by x minus 1. So that is our final answer. We proved that f is a bijective function by proving that f is 1, 1, and onto. And we also found the inverse function of x. So f inverse of x is 3x minus 2 divided by x minus 1. So that concludes this episode of CBSE board exams. We hope that you find our methods interesting and easy. For more of our useful videos, please visit our YouTube channel, Brain Blitz Audios, and subscribe to our channel. We'll be back with more useful and interesting and entertaining content such as learner words, mind maps, stories, NEET preparation, and of course, more of CBSE board exams. So until then, stay tuned. Bye-bye for now.